This video is for assignment 5.3, graphing functions, or reading function graphs and stuff like that. Let's go ahead and get started. In this, in number 1, what it wants you to do is it's telling you, hey, we know what x is. X is -5. So we're going to take that -5 and put it right there for x, giving us 4 parentheses -5 minus 3. 4 times -5 is -20. -20 minus 3 would be -23. Okay, and we do the same thing with -4. Let's see. -4. Put that in there. 4 times -4 is -16. -16 minus 3 is -19. Okay. Now we put in a 1. 4 times 1 is 4. 4 minus 3 is 1. Put in 3. 4 times 3 is 12. 12 minus 3 is 9. And 4 times 5 is 20. 20 minus 3 is 17. So all you're doing is taking x and putting x, whatever it happens to be, one at a time, right in there for x, and then solving. So that's all you have to do for number 1. Number 2, same thing, only in this case, or at least in my example, we're doing it as an exponent. So let me remind you how to deal with an exponent. If I have 9 to the -2 power, that's the same thing as saying 1 over 9 squared. Okay? The -2 just makes this whole thing go into the denominator, or it flips it upside down. So what's 1 over 9 squared? It's 1 over 81. And that's what you'd put right here. 1 over 81. Okay? Now, if we do the same thing with -1, we have 9 to the -1. The negative means this whole piece is going to go, it's going to flip in the fraction. So it turns into a 1 over 9 to the 1 power. Well, what's 9 to the 1 power? That would be 9, so our answer is 1 over 9. Anything to the 0 power is just 1. So just remember that. Anything to the 0 power is just 1. 9 to the 1 power is 9. 9 squared is 81. So all you're doing is plugging in the x's one at a time into the exponent. And the negative exponent just means you take that whole thing and put it in the bottom of the in the denominator. Or if the negative exponent is the denominator, then it moves up to the top. It just flips it upside down. Okay, here, same thing. We're plugging in x's. So if I have 1 over 6 raised to the -2 power, what does that mean? That means that we're going to flip the fraction, 6 over 1, and it turns positive. So all that negative means is that you flip the fraction upside down. Okay? So what's 6 times 6? That's 36 over 1. 1 times 1 is 1. So what's 36 over 1? That would be 36. So same thing here. If we put a 1 up there, let's see, let's do a 1 over 6 raised to the -1. We flip the fraction. It becomes 6 over 1. And then the negative goes away. So what's 6 over 1 to the 1 power? That would be 6. Anything to the 0 power is always 1, doesn't matter. 1 over 6 to the 1 power would be 1 over 6. Now 1 over 6 squared, to do that, you just do 1 over 6 and you square both parts, just like that. So what's 1 squared? It's 1. What's 6 squared? 36. So that answer is 1 over 36. Okay, now we're given a function and we're given a domain. Okay, the function h defined as follows for the given or the domain given. Write the range using the set notation. Set notation just means the brackets. So let's see. If the domain is -2, -1, 0, 1, it means that we're plugging in each one of those. So when x is -2, we're going to plug that in. -2 times 2 is -4. -4 plus 2 is 2. So that tells me, and I'll write that out, -2 plus 2. So that would be -2. So when x is -2, y is -2. We do the same thing for -1. 2 times -1 plus 2. So we get -1, comma, and 2 times -1 is -2. -2 plus 2 is 0. So there's my other point. Plug in a 0. 2 times 0 plus 2. That would be 0 plus 2 is 2. So 0, comma, 2. And 1. And I'll do that down here. 2 times 1 plus 2. 2 times 1 is 2. 2 plus 2 is 4. So when I plug in a 1 for x, I get 4 for y. So let's go ahead and put those in. What's my range? Well, what's my lowest y? It would be -2, comma, then 0, then 2, then 4. I'm just listing all the y's. Now we're just going to plot these points. -2, -2, -1, 0, 0, 2, and 1, 4. And we see that's a linear equation, or a linear function. Number 5, graph the exponential function f of x equals -5 raised to the x power. Okay, a couple things. Number 1, I can tell because the x is up here, it's an exponential function. Okay, that means it's going to curve. I can also tell this is smaller than 1, so it's going to curve down. It's going to decrease. Now there's a couple buttons here that you want to be familiar with. This one right here. When you push it, it allows you to plot the point. So you don't have to guess where it is. You can tell it, all right, put a point at 1, comma, 2.3, for example. Plot point. And you see it plots it right at the exact spot. So you don't have to guess where it is. And then this button over here connects all the dots. So let's start with 5/8. So we got 5 over 8, and it already tells us what it wants the x values to be. So -2. Now if you remember, the negative means it flips upside down, so it becomes 8 over 5, 2, 2. The squared goes to both numbers, not just one or the other. So what's 8 squared? 8 squared is 64. And what is 5 squared? 5 squared is 25. So we don't need to simplify that. The only thing we need to do is click this box right here with the x in it. And what did we plug in for x? We plugged in -2. And what was our y? Our y was 64 over 25. Plot point. See, we don't have to do any more than that. So next, we got 5 over 8 to the negative 1. So that means we flip it upside down. 8 over 5 to the 1, 1. So that just stays 8 over 5. So again, we click this coordinate box and we say, okay, when we plugged in for x, we plugged in negative 1. The answer was 8 over 5. And there's my next dot. Okay, anything to the 0 power is automatically 1. So when I do 0, 1, there we go. Now 1, if I plug in a 1, anything to the 1 power stays itself, so 5/8. So I'm going to do 1, comma 5 over 8. And then if we plug in a 2, we get 5 squared over 8 squared. 5 squared is 25. 8 squared is 64. So now we just plot that point. We have 2, comma 25 over 64. Again, we don't have to worry about what that is because the computer will do it for us. There's the 5 points. We're going to click that button, and there's our graph. Number 6, it's done the same way. Okay, now what can I tell from this? I can see right there the x is in the exponent, giving me an exponential function. And that number is greater than 1, so it's going to be increasing. It's going to look something like that, probably steeper, but it's going to be increasing. So let's go ahead and get started. 1 over 2 times 5 to the negative 2. That means 1/2 times 1 over 5 squared. The negative 2 means it just goes upside down. And that equals 1/2 times 1 over 25. And with fractions, you just multiply straight across. 1 times 1 is 1. 2 times 25 is 50. So there's my y. So that means when I plugged in negative 2, I got 1 over 50. So I'm going to plot that point, and there it is right there. Now let's go through and go ahead and do the next one. 1/2 times 5 to the negative 1. The negative 1 means I flip it upside down, so 1/2 times 1 over 5 to the 1. And that equals 1/2 times 1 over 5. 5 to the 1 is just 5. So we multiply straight across. We get 1 over 10. So we're going to say, hey, when I plugged in negative 1, my answer was 1 over 10. Plotted the point. Now we go on to the next one. Anything to the 0 power is just 1, so 1/2 times 1 is just 1/2. So when I plug in a 0, I get 1/2. Okay, anything to the 1 power stays itself. So 1/2 times 5 to the 1 power is the same thing as 1/2 times 5, or which is also 5 over 1. Then we multiply straight across. 1 times 5 is 5. 2 times 1 is 2. And that's our answer. So we get, when we plug in a 1, we get 5 over 2, just like that. And the last one, squared. 1/2 times 5 squared. That's the same thing as 1/2 times 5 squared is 25, or 25 over 1. We're going to multiply straight across, and we get 25 over 2. So there's our y. So again, we click this box and we say, hey, when we plugged in a 2 for x, we got 25 over 2 for y. We plot that point, draw the line, there's our graph. Number 7, you're given 4 different functions, and in all 4 of these functions we have slope, we have y-intercepts, stuff like that. The first part, which function of the graph has a graph with a y-intercept farthest from 0? Okay, so that can be either positive or negative. This one has a y-intercept of 3. This one has a y-intercept of -4, so 4 marks are farther away than 3. This one has a y-intercept of -2. This one has a y-intercept of 5, so I can see that function 4 is the farthest away from 0. Which functions have the graphs with y-intercept greater than -3? And that's just as it sounds, higher than -3. So that one's higher than -3, so function 1. That one's lower than -3, so not that one. That one's -2, that's higher than -3. And function 4, the y-intercept is 5, that's higher than -3. And which function's graph is the steepest? Now here, I'm going to caution you, you get several words here. Steepest or greater than, okay? Steepest, it doesn't matter if it's negative or positive. If it says which one is greater than a certain number, that just means on the number line which one has a higher number than that number. So there is the difference between the two. So which one's the steepest? This one goes down 1, 2, 3, 4 over 1. So -4 over 1. This one's -4, -2. So this one's -2 over 1. That one's 5. So 5 so far is the steepest. And the slope of 1. So we see 5 is the steepest. Again, it doesn't matter if it's negative right now because, function 3, sorry, because it's saying which one's the steepest. Number 8 is exactly the same. We got 4 functions. Which one is the least steep? Now this tells us it doesn't matter if it's negative or positive. So 1, 2 over 1, so that's 2. This one's changing just by -1, so that's least steep so far, -1. That one's got a -5, and that one's got a 4. So function 2 is the least steep, -1. Which functions have graphs with slope less than -2? So here's where I was saying. It's not saying less steep than -2, just less than. So this one has a positive slope. Can't be positive because it's got to be less than -2. This one goes -1 for every 1. So that's -1 over 1. So that's more than -2. This one's -5. So that one's -2. Or less than -2. And this one has 4. And that's more than. So it can't be that one or that one. And that leaves us with just the one function. Function 3 has a number less than -2. And which function has a graph with the greatest y-intercept? The highest, that's -4 right there. -2, 1, and 5. So 5's our winner. So we're going to go ahead and select that one. Here's the graph. What is the domain? The domain are all my x values. So I'm going to put it in brackets. Set notation, that just means in brackets. My lowest x is right there at -2. And let me draw on it so that it's a little easier to see what I'm talking about. If I draw a line right here, where's my x value? x value is negative 2. And then if I draw this line, what's my next x value? It'd be 1, and then 2, and then 4. So negative 2, comma 1, comma 2, comma 4. Just like that. The range, same thing. Y. That one goes over here to negative 1. So in our bracket, we have negative 1, comma. The next highest one, or next lowest one, is 0. See how it goes over there to the y equals 0 right here, between negative 1 and 1, 0. So 0, then 2, then 4. We just go to the where the y-axis hits. The range, we're dealing with y. So what's our lowest y? It goes all the way down to 0. And we see that is a filled in circle at 0. So we're going to do the equal to y equal to, because this is a filled in circle, at 175. So always lowest to highest. So domain, what's our lowest x? Our lowest x goes all the way out here to 0. It's a filled in circle. And what's our highest? It goes all the way out there to 35, which is also a filled in circle. And so that's what we put there. I hope this helps. Let me know if you have any questions.